All right. Sorry, this is only part one, and it's, well, anyone who was here the very first BoostCon? Yeah, there's like 3 people for sure, because you've been to every one.
Yes, correct.
Jeff and Zach and Marshall. And of course, they're not even my friends anymore. They went to the other talk.
I'm sorry, I'm here.
Yeah, thank you. I got one friend. That's good. This is still the best talk. I mean, the whole conference has gone downhill. This was like, the first year keynote, still the best talk. You can't find it online. This is one. You can find a sort of version of it online, but you can't find the original. So don't go watch it right now. But like, it was such a good talk that like the whole audience was talking after, and it was all about value semantics and everything. And Dave Abrahams, as you can imagine, was asking questions as he does, and he's like, "How do you teach this stuff?" Right? And that turned into a whole nother conversation. And it's only been 14 years, but like this is the start of my answer to how you teach this stuff. And it's just a start. And this was really a bad idea. Don't go compare my talk to Sean's. Like, just forget that I mentioned the really good talk. But it is the start of my answer to this. So Sean tends to call it value semantics and stuff. I like to call it value-oriented programming. But it turns out to talk about value-oriented programming, I don't really want to talk about values first. I want to talk about functions first. So we'll kind of talk about values and objects a little bit, but mostly I just want to talk about functions. And somewhere I had a little clicker. Where did I put my clicker? Oh, well. Right there. Does it work? Is it on? All right. Sorry, that was the, there's an extra hidden reference in the 4 dots there. I couldn't decide what colors to use until the point is that, there's going to be a lot of references in the slides. We know the lyrics now, right? You say you want to write a function. Well, Oh, man, I screwed it up. Now that is a lie. So it's Chili Peppers, right? You don't want to write a function. No one wants to write a function. You got some code, right? You've already got a function. You've got a whole bunch of functions. And you just want to change the code, right? You want to add a feature. You want to fix a bug. You don't want to write a function. You just want to like add an if statement, right? Stick an if statement in there. I really need to know, this projector is facing north or something. So why do I need to know that? Who knows? But we just get the projector's orientation from its pose, and then it's like yaw, pitch, roll, or quaternions, or whatever you use for your orientation. Lots of things you could use. Don't use yaw, pitch, roll, but that's what we use. It's the wrong answer. And then, you might be like, north is 0, and you want to be like 5 degrees within north, close enough to north. And you're like, okay, this works. This fixes my bug. And then like a few weeks later, it's like, oh, wait, could be 5 degrees the other way from north. That's okay. Now, okay, this is all working. And then, if you were, a half decent program, maybe you wouldn't repeat those lines of code and you would put a variable in. But yeah, you're not going to do that, right? You're just going to like cut and paste the code. And then at some point, these older projectors, they need, higher tolerance for north. So we got that. And I can't even remember what this code. Yeah. We're smarter than this. That's the quote there. And Anakin says, apparently not. Kate Gregory had a really good talk at CVP North last year. Am I a good programmer? And after a while, I start to question it. Right? It's like, how did this code get to look? It's not a lot of code, right? But it's still already getting ugly, I think. Are we the baddies? And so how did we get here, right? Like, we got here in 10 seconds on slides, but this happens over time. Like, the code just slowly evolves, and everyone comes in and just adds one more line to the code, and the code just gets longer and longer. So we got here one step at a time. And there's this thing called complecting, right? And let me explain. No, there's not enough time. Let me sum up. Princess Bride, right? Come on. Those are the exact words. I got that quote right. I didn't get the accent, sorry. So complecting was a talk by Rich Hickey called Simple Made Easy. And simple, he likes to go, whenever he uses words, he likes to define them, go back to Latin and stuff like that. Simple and complex both come from the word plecto in Latin, which means to fold or braid, like that over there. So simple is single fold, right? And complex is many folds, right? And easy is adjacent. It's like adjacent, is where it comes from, and it means close at hand, right? It's right here. So simple made easy. And complecting is the process of interweaving, right? And I love that word. So I see it all the time in code. It's like you've complected our code. You've entwined it all together. Right? And I did a talk. I did a lightning talk 2 years ago, I guess, on complecting made easy, because it's so easy to complect your code. It's what you do naturally, right? This is what happened. You know, we just made the code worse, but it was the natural and easiest thing to do. It's easier to write this code than to write a function. So complecting made easy is because almost every step of the way, the easiest thing to do makes your code worse. Like, it's not hard to write a function, but it's harder than not writing a function. Like even this is easier than, you know, making a variable. You're just like, I just cut and paste that code over again. That's easier. So not writing a function is easier than writing a function. That's why writing a function is a lie. You don't want to write a function. All right, so what are we going to do about this? You know, we got this if statement here. Let's copy this if statement, or this comment, put some underscores on it, put some brackets at the end, syntax this baby up, right? And then we got this, right? It is actually not that hard to write a function. And then we can just remove the comment, right?
Where do you put the code?
Well, we'll get to the code. But what about the comment? Not needed anymore.
Yeah, but you conflated two things in that, right? Because you had all this logic about serial numbers and stuff that has nothing to do with norm.
That's a good point. That's a good point. But also, yeah, I wanted this part, right? Like, we took away the comment. I still don't know why we're checking for north, right? It's like, yeah, it's obvious that we're going to check for north. And I don't know why. My favorite comment word is otherwise. I worked with a guy when I was at Adobe, and then we both went our separate ways. And like 5 years later, he sent me an email saying, thanks for otherwise. Like, he's like, I use this now, and people, you know, thank me for my comments. And I was like, out of the blue, like I hadn't talked to him for 5 years. That was it. It's an email just about that. And I was like, cool. So my reason might be because I, you know, don't have a good talk example. That's all I had. But whatever. By the way, you know, I always like to talk about naming. You don't need to say projector, right? It is a projector, so it's kind of obvious. Like string, you don't say string from it. You should say toString. You have to put parameter types in the return, but not in the. You know, you need the return type in your function name sometimes, but you don't need the parameter types in your function names.
Yeah, it's because C has no type overloading. That people write.
Well, yeah, C, but I mean, this is C++
Yes.
now. We're writing in C++ now. This kind of fits some. So there's our function. Put it over there. Maybe there's some, you know, some things you don't like of the cutting line. I've been thinking about writing another talk on this, where it's all about the cutting point between two pieces of code and how do you separate. And then I would have to do it all in haiku, right? Haikus have cutting points. I might do it. Oh, well, speaking of, you know, I don't know, sort of related Asian something, I don't know. Far East. Koans, right? Everyone know what a koan is? It's like a short story. It's from like Zen, Buddhism and stuff. A short story that, you know, enlightenment at the end of the short story. So I had not me, it's totally not about me. The Padawan was asking the, you know, sensei, how do I read the config file? I need to read, you know, something out of the config file. How do I do that? And the sensei said, well, there's a function for that, right? And so the Padawan was like, well, what's the function? What's it called? Well, guess. What do you think the function's called?
Read.
Man, guys, good. Read config file, right? Maybe other times the config's not a file. I don't know. The file part, we can argue about that part, but reconfig, right? And the sensei was like, yeah, that's great. You just have to pass the file name in, right? It's like, okay, well, how do I get the file name? Like, what's the path to the file name? It's like, there's a function for that. Of course, there's a function for that too. And the Padawan was like, just to get the config path, there's a function for that. It's like, yeah. So is it like read config file, get config file path? Is that what I need to write? And the sensei's like, yes, the code is true. It didn't compile, but sensei was gone. Enlightenment? Anyone? Where's the enlightenment in this story?
Code should be like English.
Yeah, but why didn't it compile?
You should write those functions so they compile.
Yeah, the functions don't exist. These functions don't exist yet. But, convince the Padawan that, yes?
Also, this is a race condition.
Thank you. It's a race condition, yes. I'm sure it is.
Tony was enlightened.
Yeah.
He says, the sensei says that there is a function for that. Not there would be or there will be.
Yeah, but that's how you gain enlightenment. If he just gives you the answer, you have to go through the pain, right? You're like, what's going on here? And then the story sinks in. All good koans, like, you have to feel the pain of the koan. Otherwise, it doesn't stick. So functions are the answers to questions, right? It's just so often in code. You're like, is this projector facing north? It's like, well, write the function you want to see in the world. Right. You wanted a function for that? Just write it if it doesn't already exist. Just imagine like, oh, this would be so much easier if I only had this function. There's a function that we needed. And basically this is like, however decades old, top-down programming. There's nothing too exciting here. Another koan. So in this one, the master was out walking his dog, as they do. He or she, sorry. Master was out walking their dog. And they decided to stop by on a student, right? And the student was like, oh, master, I'm so delighted that you came to visit me. I'm honored that you came to visit me. And the master was like, I was just out walking my dog. By the way, well, now that I'm here, your function, why does it take big common struct instead of just X and Y, right? And the Padawan was like, oh, big common struct is where we keep X and Y, master. And then the dog barked, right? And master's just like, don't worry about the dog, he's hungry, don't worry about it. And of course, the student was like, wow, master, please let me prepare a feast for your dog. Like, I would be honored to prepare a feast for your dog. And he's like, no, just open the fridge, let him take what he wants. The thing I forgot to mention, by the way, like this one's a very old koan. I don't know where these come from, but we found that almost all of them, especially the old ones, were 140 characters exactly. And all the new ones, a lot of new ones are 280 characters exactly. Any enlightenment here?
If you give a function a big common struct, it'll use it.
Yeah. I think, good, thanks. I didn't think it was, I'm kind of hammering in kind of hard there. So this function takes a projector and it grabs like two things out of the projector, right? It's like, it didn't need a projector. And if you give it a projector, eventually someone's going to call like show video in is facing north. And the sad part is they'll do it for a good reason, right? It'll be like, yeah, that fixes whatever. Like, why does that fix whatever? But it fixes the thing. But still, it's like, it probably shouldn't have been there. Maybe you needed to call that up here. Or like maybe you don't always need to call show video, but in this very important function, it's probably not the right place for this. But you made it easy. Right? Complecting made easy. You had the function, it was right there, just call it, bam, your bug is fixed and off you go. It was close at hand. Projector was right there for you to use. And worse, in our code base, we have a class called model, and model is the world. It is everything in model. It is actually the only class in our code base in all caps. Like you have to yell it when you talk about model, right? It's like model, like this, and it is. It's you end up with the document class. It is the document class that holds on to everything. But everyone has a pointer to it, right? It's like you get a model pointer and you get a model pointer. So nothing more easy than that. If you got a pointer to model, you can do anything you want because you've got access to the whole world. So it turns out, like, if you have a projector, you also might have model because we also have back pointers to half the things, right? And then you've got the whole world close at hand, and you have like, oh, I really needed a Palpatine, ultimate power, unlimited power, GIF. I used to have one. All right. So, we could just pass, instead of passing projector into this function, we could just pass an orientation and a tolerance, right? It's like, is this thing close to north? That's all you need to know, right? And that forms a barrier to complecting, right? If you have to fix something, you might realize you should fix it over here instead of fixing it over there, right? And, and maybe you will have to fix it there, and maybe you have to pass another parameter, or things happen, but there's a good chance that it will turn you in the right direction instead of falling into the wrong direction. And this side of the code has gotten slightly bigger, not a big deal, but slightly bigger. If you want, why not both? You can have your is facing north projector, but handles the projector stuff. Because this is very top down, right? Like the problem that you had was like, I need to know if this projector is facing north. So you wrote the function, is this projector facing north? But what you can do is write top down on the way down and bottom up on the way back up. After you've written a function, you realize it only needs an orientation and tolerance. So change the function to take an orientation and tolerance and work your way back up. Either have the wrapper or just change the, pass the two parameters over here, right? And what happens is a lot of people do the top down and they don't do the way back up. So you end up with passing too much stuff into your code. And, that's, top down the way down, you just end up with this. And you got the complecting made easy. And on the way back up, you get rid of that. You at least limit it. You've limited it to over there. But this function is kind of nice and works on its own, and you can use it for other things. Keep your stuff separate. It's the new KISS. How fast am I going? I'm going really fast. I was just going to sit here for a minute.
Tony,
Yes?
I'm sorry, but there was a 5 in that 2
Yeah.
slides back. And like
That 5 is terrible.
we can't let that go.
All right. I mean, the 5 is there because it fit on the slides.
Okay.
Right?
But like it just came out of the air, obviously.
Yeah.
Because I didn't even check the projector type, which would be where
Yeah, I've lost that whole story of the projector type.
Okay.
So, maybe that's why you have 2 versions. Maybe that does go over here. It's such a, what's the word I'm looking for? Artificial example, right? So it's kind of hard to say what's the right way to go with it. But, this is the point where we can actually talk about values and objects, right? Up to now, I've just been saying projector, but projector is probably not a value type. Projector is probably a pointer or a reference or something. It's a big class. Like, it'd be great if, like, just passing a projector into a function created another projector. That would, like, my company would love that, right? Just like projectors coming out of everywhere. We'd make millions. But it's really hard to copy a projector. So projector is probably an object. But orientation and tolerance, they're just numbers. Or orientation is like 3 or 4 numbers. And you just treat them like values, right? So I would like to, my next talk will be explaining the difference between values and objects. But that's it. Like, you already know the difference between values and objects. Values, you basically don't care about the identity, like the address. Rich Hickey calls it PLOP, place-oriented programming. Because it's like the projector, has a fixed address, and you care about that, and you care about the values at that address. Whereas direction and tolerance, you don't care about where they're being held. You just care about the internals of the value or object or whatever you want to call it. I mean, in C++, everything's like those are called objects in the standard, but I don't call those objects. So also the bottom function you can test. It's safer. You don't have like a dangling pointer. It just, it's local. It's just like you can just stare at that one function, decide if it does what it's supposed to do. And you don't have to know anything else about anything to test and understand that function. All right. So this is if you want money for parens with all that state. Right? Don't pass in a whole pile of state that you don't need to pass into your function. I mean, you have to wait like forever because I'm just never going to accept it. All right. Like I said, this is value-oriented programming, but it's about functions, not values. This is what people think of functions, right? Kind of that model or that model. What's the difference between those two conceptual models of a function? Yeah?
It's rotated between time and space.
Oh. All right. All right. Anything else? Yeah?
And possibly if you stuck the same thing in, you get two different things out of it. But
Yeah.
not-
I mean, it all depends if you guys know Dr. Seuss, right? This is from Dr. Seuss. Right? This one takes sneeches, obviously, and modifies the sneeches, and then you get sneeches with stars on them. It's a star on machine. Everyone big Dr. Seuss fans, or is it just me? And the other one takes an input, produces an output, but like 17 is always 17. You can count on it. It's a number. You can count on it. So 17 never changes. You just get a new value out, right? Whereas this, you're putting something in, you're changing it, you're modifying it. So there's a book called Grokking Simplicity, and it's all about functional programming by Eric Normand. And it's not an exact quote. I've kind of like compressed his quote into 4 words. Separate calculating from doing, right? Calculating tends to look like that over there on the right. You just take some values, you produce an answer. And doing is when you actually take that answer and store it in your data structure or modify your sneech or whatever. So if we were to put a star on function machine on our sneeches, we have to measure the sneech, we got to find the belly, calculate star positions, and then apply stars onto the sneech. Oh, by the way, if you're still writing functions that return void now, you ain't going to make it with anyone anyhow. I think returning void is a code smell, right? I mean, obviously there's going to be a fair number of functions that return void, but when I see it, I stop and think whether, to me, it's a code smell enough to look and see what's going on in this function. So the first 3 steps of this function are calculating, right? You don't modify anything. Let's see, you do this, right? You call some function that calculates where to put the stars on the sneech. And then you get a vector of locations, and then you actually put the stars on the sneeches. And that calculate star position is a nice pure function that takes some values and returns some answers. And by the way, you probably don't need the whole sneech in that function. I should take my own advice. You probably just pass the sneech geometry or some subset of the sneech that you need to know to calculate star positions. And then you get your stars and you apply them. So the first function is pure, right? And this is the conference where we could nitpick what that means. Let's not do that. This is kind of from the Wikipedia definition. And if we wanted to nitpick it, we would nitpick what does same mean and what does no side effects mean. Because no side effects, you could have like an internal cache or something, which no one ever sees the side effect of that unless it's threaded, then but let's just think of pure functions as they take values, they modify nothing, and they return an answer. Nicest functions. And because with that pure functions, you can do local reasoning on the function. You just have to look at this function. You don't have to understand the whole world of your code base, right? I can just look at calculate star positions. Obviously, I have to know something about sneeches or the geometry of sneeches, but I can understand that function, I can test that function, and I don't have to worry about anything else. And I can test that function without actual, physical sneeches probably. Whereas the apply sneech, might actually change the real sneech, right? Because I actually, my code base is actually weird because projectors and cameras, like a lot of objects in object-oriented programming or in any kind of code base, like if you're writing PowerPoint or something, you have slides, those are objects. Yeah, but they live in memory on your computer. My projector objects don't even live in the computer. They're physical objects, up there. So sometimes, actually apply thing is changing the physical universe. Anyhow, is facing north is a nice pure function. You can do local reasoning on. You can test it. It's thread safe. It's got all the great properties. Anyone know who David John Wheeler is? All right, don't tell anyone. Yeah. But he's worked with Stroop, and he's done some recent breakthrough research on this problem space. The use of subroutines in programs. So it's just two pages. It's a really good paper. He says a subroutine is a self-contained part of a program, an entity of its own. Allows the coder to concentrate on one section of the program at a time without overall detailed program continually intruding, right? Just like what we're talking about. So this is a great breakthrough research. Subroutines can be more easily coded and tested in isolation, right? So, okay, it isn't quite breakthrough research, and he was Stroop's thesis supervisor, actually, in Cambridge. But, we've talked about that this industry is young, right? It's like 1951 is kind of recent. And I feel it's like recent because functions are underused, so it must be new, right? It's like we don't use functions enough. It must be, breakthrough research. And I kind of believe functions are the fundamental building block of programming. If you're writing an object-oriented code, you might say objects were the fundamental building block. But, they don't do much if you don't have functions. So I really think functions are way more fundamental than I used to think about. They're also like a fundamental abstraction, and they're just the fundamental building block. Man, I know the words to this too. Item 6 on the agenda, the meaning of life. That's right. I've got a team working on this over the past few weeks, and what we've got to come up with is can be reduced to two fundamental concepts. One, people are not writing enough functions. Monty Python fans? Yeah. All right, let's talk about member functions. Why don't we make this just a member function of projector? Right? That solves maybe some of the problems of like tolerance and all that kind of stuff. We just make this a member function. We could also, cameras, they can face north too. We can make that a member function. Sure, that's good. Hey, maybe they're both devices, so we could have a base class of device. We actually have a base class called device already in our code. We could put is facing north there. Oh, we also have media servers. They're also devices. A media server is, what it does? It serves media. Yes?
Are you gonna have a north class?
Maybe.
You can dot is projector.
Yeah, north dot is projector.
And dot is media server. That'd
Yeah.
be great. Do a north class.
Next time. Media servers, they pump the video that goes into the projectors. That's what they do. They serve media. They really are. It's a good name. They don't have direction other than out the server into the projector. They don't face in a direction. So, we could have directional devices. We could also have the media server is facing north, just return false because it's not facing anywhere. Or we could have directional devices and non-directional devices. And at some point, it's like, Anakin, you're breaking my heart. I can't go down. You're going down a path I cannot follow. Should I only do 4, 5, 6? Is that? I should avoid 1, 2, 3. All right. I can work on that. No, there's still another one coming. Sorry. Maybe you were doing this because you wanted to share the implementation of facing north or something like that. while at the same time allowing them to override it. It all seems to make sense in an object-oriented world. But a good way of sharing functions is like writing a function. It works so well. You could just like call it whenever you want it. Right? So we could just do that, right? Like camera, maybe the way you get orientation from a camera is different or something. Like you could just do that. Functions are for sharing. That's what they're for. So what about putting, we could have a north class like JF suggested, but what about just putting is facing north on orientation, right? Like what's the difference between these two? And in fact, to the compiler, it's probably nothing, right? These are going to get inline and turn into the exact same code. So does it matter? Anyone care? Is it Friday, the last talk of the week?
Free functions.
I would say these are isomorphic.
The function pointer of the left-hand side is way nicer than the right-hand side.
The function pointer on the left-hand side. Oh, yeah.
It's
One's a
way
member function pointer.
Yeah, which is horrible.
Yeah. I mean, I always like to ask Link about these things. So every time you add another function to your class, right, it just piles onto your class, and your class gets heavier and heavier. And you walk slower and slower. Because classes are made of Velcro, right? You just keep sticking stuff on them. And I just don't think you need to do that.
I would keep orientation part of the together with the position and use an auto transfer.
Yeah, right. But you probably wouldn't have a specific function for facing north, right? Here's another example. This is our camera. This is like I've worked at a lot of places, and everyone has bad code. Okay, right? Like, don't hold my company accountable. Like all the code I've ever seen is bad everywhere. This is our camera class. It really has all these things in it, and I like to separate all these things into different like pieces of the camera class. Like one of the weird parts is it does have a pose and a calibration and stuff, except for when it doesn't, because when you first start up our program, we don't know where the camera is. We have to like take pictures and stuff and figure out where the camera is. So it's like, it's a class that, and all these things, like half of this class is invalid part of the time, right? It's one of our worst classes actually. But what we've done is basically someone said, well, it's the camera class. All this stuff has to do with the camera. So you put it in the camera class, right? And you form like what I like to call a nexus. Like you've just taken all this stuff and it's like a nexus of complecting. You've put all this stuff close together and then say, hey, use it. And how much of your code is gonna like, every time you change any function on the camera class, you risk affecting all these other pieces of the camera class. So the other difference, right? This function is going to use an external orientation API, right? It's going to use orientation somehow. It has to use the external API. That one probably just going to access the internals. So if we change our orientation from being yaw, pitch, roll, X, Y, Z, then we changed it to quaternions, and then we changed it to rotors, all these functions are going to have to change. But not this one. If you keep it outside, that one will have to change, right? You change anything about orientation, all the member functions have to change, or potentially have to change. And you're going to miss one. And fixing something in orientation here is going to break another member function over there. So what we want is orientation to have like what we like to call a basis set of functions, set of basis functions, right? Of here's the functions you need in orientation, and everything else can be outside of it. And I like to say that good code begets good code, right? The code could be fine right now, but you're leading the next person into a trap, right? The next person who goes to change the orientation class is going to have a harder time. So the code might not be bad now, but it's going to become bad. And it's really weird that it turns out that you can't see what code is good. It seems like you can't see what code is good until years later. And then you look back and you go, oh yeah, well this code actually changed over time and is still robust and everything. Whereas this code just went downhill. It's like, well, it's probably bad to start with. You just didn't see it. And also, if the definition of good code was just begets good code, it's like the same definition of bad code. Bad code begets bad code. The only difference is good code works. So, I don't even know if I want to talk about invariance, but yeah, every member function has to maintain the invariance of the class. You guys all know this. It's preaching to the choir here at this conference. And so this one doesn't have to worry about invariance. They're not going to be broken even for a moment. And this is also 23 years old. Scott Myers has a really good article on this, how non-member functions improve encapsulation. You should read it, not right now. Read it later. How many string functions are there?
Too many?
Functions on stood string or string functions?
That's a good question. Let's start with how many functions on stood string? 200?
100?
Yeah, there's like 200 or something like that. It's way too many. But I actually did mean, how many string functions are there? Like, like this, even if we just limited it to this, right? Like, or functions that take a string or return a string, right? How many?
Thousands.
Did someone say uncountable? Because my first question is it infinite? And my second question is which infinity? Right? And it depends.
4
Yeah.
or 5 useful ones.
4 or 5 useful ones. That's it. Yeah. The rest are, But and this seems to be the right place to discuss the infinities.
Do you mean in the library or in principle?
Well, yeah, right. Like in principle, your computer is infinite, but really your computer is finite. So you can only have a finite number of string functions, right? But if you think in terms of just the programming language, you can have an infinite number of string functions, right?
It depends on your model of set theory, right? It is independent of set theory.
Yeah. So which infinity? Is it countable infinity, or maybe you could figure out that it's uncountable infinity?
That
But
depends on your interpretation. It's certainly not countable, but it could be the next Aaahhh, but it could be also higher.
Aleph 1, yeah. There's a lot, right? That's my point. Whether it's infinity or not doesn't really matter. There's a lot of string functions. How about we put them all as member functions of standard string, right? So for some reason we don't do that, right? So for some reason we decide to not everything needs to be a member function. So does anyone want to vote on this? Is anyone like who likes that side? Great. See, I don't have to ask who likes this side. I just say no one liked the other side, and I'm going to assume everyone liked this side. Does everyone like this side? Yeah, it's pretty. I mean, this audience, you guys are easy. So I think is facing north should be a non-member function. Did I have anything else to say that? Yeah, not everything should be a member function. So this is where we're at. How far are we through the song? Anyone following? All right. About halfway through the song, I think. Maybe a little farther. All right. See, like Link look how fast he moves without all those functions on him. And then, you got to tackle the next, challenge, right? You say you change the param direction. So what I want to talk about is like in-out parameters, right? I like in parameters, but sometimes you have in-out parameters. Obviously, orientation, you probably wouldn't make an in-out parameter. But say I have a function that takes a vector, does some other parameters, probably modifies that vector for some reason, right? Or you could have a function that takes some stuff and returns you a vector, right? And nowadays with Value Semantics, it's like one's just as good as the other pretty much, right? I really like this one better, right? Yeah. There is a time where this is less efficient than doing this, right? Because in this case, if you put 100 items in the vector, you clear the vector, but there's still the memory for those 100 items, and the next time through, maybe you do 50 items and there's no allocation, right? So there is a time where this is valuable, but most of the time, I'd prefer the other way. And once again, why not both, right? I would make, I didn't mean to say fugly, but that's like I typed it, then I was like, oh man. You might want to make the one name a little uglier so that everyone tends towards this function, because at the end of the day, when I see this, imagine this ... is a lot bigger, right? And you look at this line of code and you're like, oh, I wonder what that line of code does. It's kind of hard to tell what that line of code does. That line of code, it takes some stuff and it makes a vector. I don't even have to look at what the function is. I can see, it takes some stuff. That function, I'm going to, especially if I start writing all my code in a pure functional style, I'm going to assume that that doesn't touch any global variables or anything. Whereas this, which returns void, I'm like, ooh, what's it change? Like maybe I can figure out it changes vector, but maybe I'm like, ooh, does this change global variables? Does this change, is it a member function? Is this like, what's this changing, right? That also could be changing global variables, but it's probably not, right? So when I'm looking for where the bug is, I probably won't start over there. I'll probably go looking over here, right? So it might be valuable sometimes, but it's harder to read. It's harder to know what's going on with that function. I mean, you could also name the function something better than f, but yes?
I mean, at this point,
Right?
is there any, I mean, if you just say plus equals b on the right-hand side,
Yeah, plus equal?
is it going to be any worse than,
No, I don't want plus equal, right?
well, you do because you're going through the,
Right, I don't want to add them
you
up.
clear every time.
Yeah, I was clearing. But
But
yeah,
you- But you've allocated over here, right?
Yeah.
You could, reserve.
Yeah.
And then,
like someone could tell me that compilers could figure this out and figure out that, hey, I could just reuse this vector. Wouldn't that be better? I don't know. I think it's a whole nother topic. SppNow, when he started talking about regular, right? And he wants in regular being, be like int is regular, right? Int copies are separate. If you change the one int, the other one doesn't change. They're not connected in any way. Equal does what you think it should do. Copies are equal, and there's also like less than and stuff, but let's forget about that. SppNow wanted to be able to declare your class as regular, such that the compiler knew it was regular. So the compiler could do more optimization and be like, oh, I've got this thing and it's the same value, so I can do substitution, or I can like sub-expression substitution and all this stuff that the compiler does on ints and things because it knows what an int is, and it can't quite do in your class unless it can see into your class and like inline everything. But imagine if it couldn't see inside your class, but it just knows your class follows the regular rules. Then the compiler could suddenly optimize it better. So you can imagine like if the compiler knew the rules, the compiler, because it's standard vector, could know the rules about vector better. But for any class, you could give the compiler more information about, hey, look, my class works the way a class should work. So, optimize to it. It's hard to see. This is basically what I already said, right? It's easier when I'm debugging. I probably won't go look at that f unless, vector is the problem. Then I'll be like, oh, you created the vector. What's going on? But, this one I'm just a little slightly more suspicious of. It might only take me 10 seconds to go look at the signature of f and see, oh, it takes the vector and, The other problem with a function that takes vector by reference, I don't know if I'm supposed to clear every time. Or it's like, oh, does this function clear for me? And, fill in, does it expect an empty vector? Anyhow. So I don't like out parameters. Sometimes they're needed, but not a big fan. Speaking of names, I'm sure somewhere in, f, right, I was talking about f. I always speak of names, so I knew I would have at some point. Calc star pos, probably should have been calc star positions, even calculate, but I wouldn't call it get star positions because it actually does work, right? This is just a little, because I'm trying to just talk about everything about functions. When you name your function, like Kevlin Henny doesn't like the get at all, but whatever, get's okay. I just want to make sure if it does something like, determine sounds like, I like calc for things that are actually mathematical and stuff, but give me a sense that it's doing work. Your find, I expect find to be linear at worst, right? If your find is n squared, then go home and rethink your life. All right. Also, again, don't put param types in the name of your functions. It's just, unless you're writing C code. All right. I know what you're thinking. You're sitting there and you're saying to yourself, Tony, which is a weird thing to say to yourself if your name's not Tony. But You're saying, Tony, those were all stupid examples. They were all fake examples. What about some real code, right? All right, here's some code straight out of, my code base. I tried to hide the actual interesting parts of my code base so that people at work didn't get pissed off. And this really is, so what I did, I searched for step 1. It's a really good thing to do in your code base. Just search for the string step 1 and see how many times you find really giant functions. And not only that, but I found the exact same step 1 multiple times. Right? So step 1, it says it turns 2D camera points into 3D points, and it really does. And then it goes on to do some other things. Sean Parent, no raw loops. Maybe a bit extreme, but this might be a good, I like at least looking for loops and seeing if it is a good cutting point. Sometimes the whole thing is a good cutting point, and sometimes I leave the loop and make the internals a function. Just like loop over these things and call this function on each item. And it all depends. I really need to do a talk on cutting points. But this function does seem like very step 1, step 2. There's a fairly good cutting point between the two. And one of the things if I had all the code here, you would notice that a bunch of these, maybe I already threw some out, but there's a bunch of local variables that are just useless after this point, right? They're still there, but they never get used again because they're only used for step 1. So, make a function. It's that simple. Hey, look, validate fit. It's not even called step 4. It was called validate fit. Wow, it's just like so simple. Here's another example. I'm not trying to say he's a bad programmer. he's a good programmer, right? It's a really good article. You should go read it. Not right now. And it's about, so his whole thing is events, like say foo and bar are events, and these are receivers of the events. Like these 3 receivers have said, call me when foo happens, and these ones said, call me when bar happens. This is a map to vectors, and that is a multi-map, right? Either one works, right? And that's what his whole article is about, is like, which one of these is better? I naturally go to this one, but that's not the point, right? So here's his code. He wrote this code. I added some comments to what's going on in the code. Part of the reason, well, I'll get to that in a second. That's the case of the map to vector. And this is the case of multi-map, right? Multi-map, you get back a range. You call equal range. You get back a range, and then you loop over the range, right? But the comments are the same. So the reason I really found this interesting, because I had just written the same code in my code base, like the same name. I called it mediator. He called it event mediator, and they're both taking events. Like it's literally the same code. This is why ChatGPT can write code sometimes, right? It's like we've all written this code already, right? So this is my version of the code. Calls get listeners, and for each listener. And I kind of think I was lucky this time that it happened to be written that way. I just as easily could have written the other way. I don't think you need the comments anymore. Right? The code tells you exactly what it's doing. I don't even think you don't even need a comment about why it's doing it. It's like the function's called notify listeners. It gets all the listeners and notifies them, right? I have a whole talk on why you shouldn't do the observer pattern is broken in threaded code, no matter how you do it. So I still had to do it some way. So mine's called non-blocking notify. If you like grab a lock or something in there, like the whole thing, doesn't always go in trouble, but just please don't put a lock inside of that. You'll end up with deadlocks. So which one am I using? Map of vectors or multi-map?
I guess.
Yeah, right. I don't know. I mean, I do know because I wrote it. But it doesn't matter, right? It's like, and what I find happens a lot is that people will write nice, I wrote my nice class and I've got some nice functions and a nice API. But as soon as I step into one of my member functions, I'm like, oh yeah, let's get to the, bits, right? And it's like, well, you could just, write functions for yourself inside your class that are just helpful little functions like get listeners, right? It turns out my get listeners actually does some filtering or something as well. So that's probably the only reason I put it in a separate function. But let's forget that. Let's say I put it that way just because it was like natural for me. This is obviously not always true. You pick the wrong abstraction and your whole life goes down the drain. But often details will change. But like the point of this whole class is you get events and you call listeners. That part's going to stay the same, right? So let's pick on me instead of people on the internet. This is from slides I did on lock-free programming way back when. And this is one big function that does push. And especially lock-free programming, I have a tendency to write bigger functions. I'll explain that in a second. So first of all, no raw loops. I've got 4 of them. I've got like triple indented loop there. But I need to. Like this is how it works. But in lock-free programming, like in most classes, you go into a member function, you're trying to maintain the invariants of the class, but you break them inside the member function as long as you restore the invariants before you leave the member function. In lock-free programming, you never break the invariants. No, not even on a single line of code, not within a line of code, because another thread can come in at any time and seize the state of your data at that point. So the state of your class has to always be valid. Whatever your invariants are, always have to be there, right? So I have a tendency when I write lock-free code, it's like, man, I need to know the state of everything right now so that like I don't mess anything up, right? But it's kind of weird because actually you can't do, it's so hard to do local reasoning in lock-free programming because you can't just think about the push function, you have to think about the pop function at the same time because they are both changing the same data at the same time. But it's my excuse for why I wrote this big giant function because I just feel like I need to know what's going on. Like don't hide anything from me. But at the same time, nothing is ever hidden from you. Like if I make a function called find tail, which is what this part of the code's doing, it would have been great if I put comments in this code. But this part's doing find tail. That find tail function has to work all the time because you never break the invariants. So I can put it over there and just look at that code and say, that's how you find a tail. That will always work wherever you call it because it's lock-free. Except for the fact that it has a precondition. So, whatever. But most of these functions are like, you can think of them in isolation because you have no other choice to, like, they're as isolated as they can be, whether they're there or here, because you have to have all the functions at the same time in your head and the state of everything in your head. Because lock-free programming is weird. So it's fine. You can put them in a little function and think about them in their little function. And I don't know. Am I a good programmer? I don't even know in this case. This is kind of on the line for me whether this is better or the other way is better. But like, no one knows what's going on here, right? But it really is. You try to find it's a lock-free queue. You try to find the tail of the queue. You try to write the value at the tail of the queue. And if it fails because some other thread was doing something, you try again. And you have to refine the tail because it could have moved, and then you try to write it again. It's pretty simple, right? This doesn't look simple. All right, here's another one from a committee member. We won't say who. They, had this question, why don't we have a lambda inserter? So when you call standard sample, you are passing an output iterator, right? And you can do like back inserter to make it call pushback, right? But it's like, why can I only call pushback? Why can't I call any lambda I want, right? So if you happen to have a class that doesn't have pushback, instead you have an add, you called it add instead of pushback, you can't use a back inserter. So either you're like writing this whole wrapper to have pushback, or, I need to do this instead. And it's like, no, you don't. Write the functions you want to see in the world. You're like, why don't we have this? And it's like, well, just write it, right? So either write the lambda inserter or write your own sample function that takes a function per sample. Just write the functions you want to see in the world. This is straight out of my code base. This function, as you can imagine, gathers image data. And the first thing it does is gets the thing out of the state and uses the DS, and the rest of the code uses the DS, right? So first of all, this isn't a pure function at all. What did I want to say here? Yeah, the reason we started to refactor this code. This code was, this was a problem that we get the state and get the DS because we wanted to call this code on multiple threads. So I want to turn it into a pure function because it's so much easier to make it thread safe. And like this, Cohen, we're passing too much. We're not even passing it. We've got mstate and we should have been passing ds into this function, right? Is the top down and bottom up? Yeah, because someone just wanted to gather image data. They thought this would do it, but they could have, on the way back up, realized after you've written this function, you could realize that, look, it only uses, literally the rest of the code only uses ds. It doesn't use state. Obviously it uses the parameters, but the rest of mstate isn't important. So on the way back up, after you've written this function, you should have realized, oh, I should just pass ds into this function. But we made it easy because state was right there for you to get. And returning void is code smell. This function gathers image data. I would expect a function that gathers image data would return the image data. That's what the function does. Doesn't do that. It sticks it in state. That's what it does. This is another one. Same sort of idea. Add correspondences. Correspondences are this point in the projector matches this point in the camera. And that's how the magic works. It literally is 150 lines of code that calculates the correspondences. And the last line of code pushes it into the member variable, right? I don't mind the 150 lines of code. It's a complicated function, whatever, I don't care. Could you please just do this outside of this, right? And we've changed the code because I want to, what the code does now, it does 2 or 3 different ways of calculating the correspondences and picks the best one. But before, it's we're like, oh, how are we going to do that? And immediately you realize if this function didn't change anything, if it only calculated something, it'd be so much easier to test and so much easier to reuse this block of code. Also, returning void is a code smell. Yeah, it's not void, but it really, maybe it did return false up here somewhere, but it's you could have returned the set of correspondences, and if there was nothing in the set that, or something, return an optional set of correspondences, or yeah, it's basically void is what it returned. No one looks at the return value anyhow. All right, so now it looks like this. I would have called it calculate correspondences, but it's got a name that suggests that it does a lot of work, and then you set it. It's like the same, but I can now reuse determine correspondences. I can now test determine correspondences. So much of it, And you could kind of think well, until you needed to reuse it, there was no need to refactor it this way. But you could have just, I think it's more natural to have a function that's oh, I need to calculate all the correspondences. Calculate the correspondence, return it. This was no harder to write than this. They're the same. So just write it this way. Right, and that's kind of my last point is people sometimes say, well, it's I don't know how the code's going to change over time. I can't predict the future. Where's this code going to go, right? And I don't think you need to predict the future, right? All those examples, and we could have just sat up here and I could have just showed you my code base, but someone would probably not like me doing that. But I could have just showed you my code base or any other code base and found 100 examples of this. Every day I just see especially the separate calculating from doing. It's all over the code. And it's pervasive, and every time that we try to do anything with the code, we realize, it should have been done the other way. But we could have just, there was nothing stopping us from doing it that way right from the start, right? Return, separate calculating from doing, return a value, all these things. You don't have to be oh, I wonder how the code's going to change over time. It's no, just do that first. Just do that right away at the beginning. That's not I'm not saying figure out your whole, your whole abstraction of your whole code base, right? Sure, that's hard. That'll change over time. But if you write a function and it's a pure function, and it just sits there, that's probably not going to change over time, right? Like, yeah, bothers me. Yeah.
Do you acknowledge that it's easier to not do that and say that we should do it, even though it's not as easy?
But it's the thing that gets me is that it's not really, it's this much easier to not do it, right? But it's so small. It does get bigger when I didn't talk about this, but it gets bigger when you realize you're like, oh, I'm just gonna write this function separate. Then you're like, oh, where should I put it, right? It's like, oh, I should put it in, no, not that header. No, maybe that header. Maybe I should make my own CPP file, right? And it's like, oh my God, making a CPP file, that's hard, right? But I'm fine with, I often tell people, just put it at the top of your, whoever's calling it right now, just put it up here. Just put it at the top. And then if it gets reused, it'll migrate higher and it'll migrate out of here over to someplace else. That does risk the chance of you writing that same small function in 3 different CPP files. That's not the worst thing in the world. You'll probably see that eventually and turn it into one, Yeah, it's so small amount harder to write a function. But often you're like some of these, like this, the hard part was determine correspondences. Like there was no extra effort to separate that. It was like determine correspondences was months of work, like literally months of work. What was that about? Functions again. People aren't writing enough. That's it. Yes.
You keep saying returning function returning void is a code smell. Now, I can see that if you're referring to global functions, but especially in the case of member functions, how is forcefully, as in your last example, always returning true any better than returning void? I mean, that function actually does something. It mutates the local state, which is perfectly fine. It doesn't mutate some global state.
Yeah. This function is a fine void function, or bool, or whatever you want to, It's a void function. That's fine. It does what it puts the correspondences in the class. Like, this is the other thing that bothers me about this. It's called add correspondences. So you would think one of the parameters would be the correspondences. Like, it's called add, it doesn't add correspondences. It creates them out of nothing. It creates them out of images and stuff. And the real work, the real function is determine correspondences. But as soon as you make determine correspondences, which returns a value, then, I don't care that this is void. But I see big giant functions that do a whole pile of work and it's void. I'm like, I bet 90% of that work wasn't changing the modifying the state of the class, right? It was a free function hiding inside a class. Yes?
For functions like you've shown here, would you advocate for just removing this function entirely and just having 2 lines of call site instead of 1?
Yeah, maybe.
Like if you just
I know what you're saying. I'm wondering whether I care, right? I care so much about the first function there that, I don't care about the rest. Like, as it turns out, in our case, add correspondences is gone. That function, I literally just typed this in today. Because we are calling determine correspondences multiple times and figuring out certain things about the state of the world to figure out, like, oh, we should go down this path. This gets us the best correspondences, right? So yeah, in our case, you call that multiple times in a loop or so. I forget how it works, and then push back once at the end. So it's
I believe that code like that happens because initially there was the intent of avoiding the performance implication of creating the set of correspondences in this case. So I think that what this requires is more than encapsulating what the original programmers wanted to avoid into its own function, just something harder even, which is to change the logic so that the thing has a different name or whatever, which would be like a update correspondences as opposed to the term correspondences. Because very clearly I see this anti-pattern many times, which is like some programmers think that creating an intermediate, a temporary with a set of something is going to be less efficient than doing it in situ. And then there are all of the complications of mutability of doing things in situ, lack of local reasoning, etc.
Yeah. How do I summarize that in reply? And I might not even caught it all because it's Friday. There's a couple things, right? Like this returns a thing. It's not in situ. And I don't care if there's any performance hit to return it. Anyway, it shouldn't be because of move semantics, but I don't care if I create more data temporarily because determined correspondence is the thing that takes time. The other thing you were saying, I do see, and maybe you were going in a different direction. I do see a lot of times developers who I've seen code where it's like find the max value in this set of things. And how does this work? They generate a bunch of, it's generating values and finding the highest one. So they generate them all, put them in a set, and then find the highest one. It's like, you could have thrown it out as soon as you knew it wasn't the highest one, right? And so you do get a lot of times where people create temporary data in the middle. It all depends, right? Sometimes I don't care. We all care about performance, but I actually, for most of us, sure, if I'm writing games or something, but most of the code in my application doesn't need to be fast. There's only certain paths of code that need to be fast. And I will do all the tricks to make that fast. Everything else, I'm like, do whatever looks cleanest, right?
No bugs.
Yeah, just first of all, let's not have bugs. And then, So I don't even know if I answered your question very well, sorry.
I was just making the comment, more than a question. This also happens with getLine, okay?
GetLine, yeah.
Yeah,
you get
getLine.
You get a whole line.
Instead of having something that returns to you the line, it uses the mutability on one of the arguments.
Yeah.
Okay.
Yeah, I mean, in things like that, maybe it's better to pass in your function that you want to iterate over the lines, and then you never, you go through the buffer or the line or whatever in place with string view, and you never even leak the line out. You pass in the function that you want to do per line.
Exactly. So what I'm saying is that this is an anti-pattern, and it requires for the developers to either feel comfortable of using temporary values because that is the logic that they have, or to re-architect the work so that they do something different if the existence of the temporary would be an issue.
Yeah, I mean, so the real question is, what do we do with those correspondences after, right?
Yes.
Yeah, but that is very disjoint from what we're gaining there is the separation, right? The code that takes the correspondences, there's 5 different things we might want to do with the correspondences. So we could, pass that in as a function to the set of correspondences, but we actually want to keep them around for certain reasons. So, yes?
Yes, so I'm all in favor of value semantics and what you call value oriented. But I will reserve it to things that abstractions that live entirely inside of the machine in some sense. If you're controlling something on the outside, like your example, the projector,
yep.
There is something about reference semantics that makes sense because it's outside, right?
Yeah.
You are referring to something. You can suddenly not copy that projector.
Yeah.
And suddenly projector is now a reference and it has a value there, right? It has some value conceptually, that's what I'm saying.
Yep.
And if you want to simulate the projector, then you have simulated projector, which is a different thing. You might have a lot in common and you might convert one into the other or manipulate one from the other. But it's like reference semantics has some value and when it's something external to the machine, you don't have any other option.
Yeah, completely.
Yeah.
Our projector class is classic object-oriented, right? We've got a base projector class. I mean, we really do have a base device class. Like camera and projector, maybe we can argue about the details, but camera and projector share a lot of device. There's a device at the bottom. And we have multiple different models of projectors. They all, thankfully now they mostly work the same way, but at a time it was like, you got to talk to this one this way, you got to talk to this one the other way. And we do have a simulated projector. We have a whole full simulation environment that fakes the cameras, fakes the projectors, has a ray tracer to get the light doing the right thing, and it's awesome. But to me, it looks like a projector, and it's like it's running on a separate server. It's like web-based and everything. It's the coolest thing. And I just talk to it thinking I'm talking to projectors. And yeah, it's classic polymorphism and classic object-oriented. You know, Sean's not going to be my friend anymore that I said this, but it's a decent use of polymorphism. You still have, and I've been trying to figure out ways of avoiding passing this pointer around everywhere, right? And we end up with a lot of functions that didn't really need it. They needed the ID of the projector, but they get a projector, right? And then it's like, who even owns this thing? Who's going to delete it? Like all these kind of problems. And sure, shared pointer is as good as a global variable. But like there is an owner to the projector. It's the model. It owns everything. And so much of our code, so I now have a projector ID, which is its own, you know, it's just a string, but it's a strong type. Projector IDs and camera IDs you can't mix them up. And a whole bunch of code is just like, look, you only need an ID. And then somewhere along the way, someone's gonna be like, I need to turn the ID into a projector just for now. And to a certain extent, that could maybe be a reference instead of a pointer. You know, or, you know, except for the case where you don't get one back, but you could deal with that. And then we could not have projector pointers all over our code base. Right?
Yeah.
Yeah.
So regarding void functions, like a lot of functions that return a vector, what they do is first they allocate a vector with some size, and then they fill a vector.
Yep.
And the second part could be moved into a separate function which takes a span and fills it and returns probably a void.
Yeah. 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 I have realized that I've tried this in the past of like, I shouldn't assume it's a vector, right? And then I realized, no, I use vector everywhere. Like, it's just what I use. Like, it's going to be a vector. It's never going to be a list. It's never going to be a thing or another thing or another thing. So yeah, I think you're right. Like you could have, sometimes you'd be like, look, this function could be even more generic if it went over a span or if it went over a, you know, iterator, you know, like we could turn it into a template. But I've got functions that are way too big to be turning them into templates. And I finally just said, look, I know it's a vector. 20 years from now, it's still going to be a vector, almost guaranteed. Or I write my own vector or something if I finally, you know, but it's, yeah. And so, you know, maybe it's, even if it was like half the function should be void. Right now, it feels like 80% of my functions are void. Like I don't know what the you know, I don't even want half. I think it should be 20. It's 80-20, it should be 20-80, right? Or something like that. So it's obviously, you know, a function that draws a button on a screen, you know, it doesn't return anything. The output went out of the computer or out of the program onto the screen, right? There's a lot of functions that are going to be void, but not as many as we got right now. Anything else? Good?
So basically, I think that, or what I take away from your talk is that a lot of things are actually common sense.
Yeah.
And they're not done because they're not as easy, or because we're not in a mindset of like introspection as we're writing our code. And I wonder what you think like maybe tools or tooling as part can have in those in this area, and what do you think?
Yeah, like to summarize a bit, a lot of it's common sense, right? And it's just how do you convince people to just do it and get in the habit of doing it, right? I forgot to mention at the beginning, the reason I put up Sean's thing there and everything was like, I mean, it's this talk is almost not for this audience, right? We're the ones who tell everyone else, like really, like this conference is kind of special, right? We tend to be the people that are telling the rest of your team how to do things. So my real goal here is just to give you stuff, right? And like literally to give you really short words to just be like, look, separate calculating from doing. Like at work, I'll just be like, dog, fridge. Like, remember the dog in the fridge? And then they're like, oh yeah, dog and fridge. Okay, Tony, whatever you say. But it's like it's, I think there's value in like pithy little, you know, like, hey, just separate calculus from, like, it changes every week to week, but lately separating calculus from doing is my favorite. Like I just keep going back to that because it doesn't fail me. It's never a bad idea. It's just like, oh yeah, great. So yeah, that's like the actual point of this talk is to just like, hey, steal my phrases, Anyone? Yep. Yeah, the projector face. You know what? The real reason for projector facing north? I don't like giving the same talk twice, but I gave this talk at CPP North, so I needed an excuse I needed a function, Yeah. Maybe the sunlight, something. No, we don't have. In the real code, we have no idea that projector's facing north or whatever. All we ever figure out is where is the projector relative to the thing we're projecting on. Yeah. Good point. Yeah. Yes.
Regarding the same function, like is facing north. If it's a free function, then you may put it like in arbitrary file, like separate from projector. Right?
Yeah.
Suppose you have a concept of a thing that knows about north, and for a projector, this concept value would change depending on whether you included your free function or not.
Oh.
What do you think about this problem?
Yeah, I mean, just don't do that. I mean, you should never write code that changes depending on whether you included this or didn't, right? Including something or not should only say it compiles or not, basically. Hopefully it doesn't change the meaning of next to anything. But related to that, you do end up with this thing where you end up with projector utils.h in CPP. It's like you got the projector class, and then you got like, here's a bunch of functions. And people are like, well, why aren't they just on projector? And it's like, because all these functions don't change when you change projector. Well, not all of them, but like a lot of them are just projector utils, and they are fairly stable the way they are. And you can change projector and put in different projectors, and I don't know. It just works out better. People just don't want to write the first projector util function because then you have to make a new class. And it's harder to define, right? We don't, projector dot, and then your IDE fills in a function. Get a better IDE. I don't know.
But what about the concept?
The north concept? I don't know. North's not a concept. We can talk about it later. My brain's too. It's Friday. It's the end of the day. Maybe I could. Yeah. Let's talk about it later. Anything else? Yeah.
Well,
you're still going on about tolerance, aren't you?
I mean, the program committee should never allow you to make this talk because you can't have just part one.
Yeah. I should have put up the slide. The next part is called part 5. Because it's part V for values. It's called return of the values. And then you're going to tell me that's not episode 5. Like, I know, but it's just the way it works out. So it'll, come to CPP North. Sorry.
Okay, sure. But what I was going to say is, thanks again. The calculating from doing. That is, I feel like, really a brilliant insight. Somehow escaped all this time. But what I was going to say is it's fascinating to me that here we are, what is this, 14th year? We're still talking about this topic.
Yeah.
We were talking about this topic the first year.
Because so like...
Apparently it won't die, right? Like apparently there's something important.
Yeah, there's something there. And like literally what I've been trying to do is like, I want to talk about value semantics, right? And Sean talks about value semantics but every time I start talking about it, I end up talking about functions. So I was like, okay, just get that out of the way, and then I can talk about classes, right? So, and I'm scared to give the second talk. Like I actually wanted, my goal was to switch talks here. Like just show up here and be like, pretend you're giving the second talk and write it, because that's what I do. I write my talks while I'm here, right? We all know that. And then it's like, it just didn't have the real pressure, so I didn't do it, right? So, but of all my talks, it's the one it's hard. Like, it's like Dave asked, he's like, how do you teach it? He's trying to teach it, Sean's trying to teach it. And it's just like, it's simple things, hard to teach. So yeah, that's why we haven't got there yet. Some of us, some people are there. I'm trying to get there.
Well, I mean, I still think we yeah, I mean, I still think we don't know how to unify the whole space, and it didn't occur to me until your talk here that, oh yeah, we have to examine the intersection of value types and functions, and it's not just about value types.
Yeah, it's a lot about functions because it's local reasoning. I mean, go read CppNow, right? Like,
Sure.
yeah, that guy just. Yeah, I wanted to quote it from like he hates objects, like it literally hates objects.
Yeah, so CppNow hates objects but loves pointers.
Yeah, he hates objects but loves pointers, which is now hard. It's like, should we change how we do iteration, right? But that's a whole nother topic. Anyone else? Let's be done.